Section 4.2, slope of a line. So we're now going to look into some more, detailed aspects of graphing, and that really starts with the slope. Slope we can look at a couple different ways. I will start by first actually defining it. Slope is a number that really describes how steep a line is. So it tells you how much at an incline or how much of a decline a line really is. You think of slope in real world situations, the slope of a hill, how steep is that hill that you're having to walk up or walk down. The steeper that hill is, the harder it is to walk up or down, makes it more dangerous, and that would be a larger numbered slope. A smaller numbered slope would be something that's a little bit more flat. So a hill that's not at very much of an incline. Some aspects about the slope that we should kind of already know, but if not, we'll review here. If you have a positive slope, that's going to result in a line that rises when you move from left to right. In other words, the line is going to look something like this. As you move from left to right, as you're moving from left to right, that line is going up. Whereas if you have a negative slope, the number that indicates the slope is negative, that's going to result in a line that drops. As you move from left to right. In other words, something that may look like this. Okay. So that would be your positive slope and negative slope. One of the ways that I was taught slope, some of my students had mentioned, was the slope house. It is a way to remember the 4 different kinds of slope you can have, depending on what kind of line you have. So if we draw in here the slope house, okay, we have as the side of the roof that is rising from left to right, that's going to be our positive slope, as we just discussed. The side of the roof that's dropping from left to right, that's a negative slope. But then you have the base of the house as well as the height of the house. When you have a horizontal line, like the base of the house, that's going to be a slope of 0. And then when you have a vertical line, a line that's straight up and down, we say the slope of a line that looks like that, that's vertical, we say that slope is undefined. Okay, so that's a slope house, just one way to try to remember the 4 different kinds of slope. Maybe that'll help you, maybe not, but I thought I'd mention it. Now getting into more specifics of slope, we can find slope a couple different ways. One way is if we are given 2 ordered pairs, 2 points that a line crosses through, then we can find the slope using this formula right here. If we define one of the points as an x and y coordinate for the first point, an x and a y coordinate for the second point, we can find the slope by subtracting the 2 y coordinates divided by the subtraction of the 2 x coordinates. Okay, that's a more kind of just mathematical algebra approach. We also can think of slope as rise over run. This is more useful if you're really looking at the graph of the line. So we're going to look at a couple examples where we actually have to find the slope, and we're going to use both of these methods. So our first example, find the slope of a line that passes through the point 2, -1 and also the point -5, 3. So we need to start by defining which point is going to be our x1, y1, which point is going to be our x2, y2. It doesn't really matter which one you make which. I am going to call this one, since it's listed first, our x1, y1. Our second point here, our x2, y2. Again, it doesn't matter which one you call which, as long as one is an x1, y1, and the other is your x2, y2. So now using the slope formula from above, m equals, we're going to do the difference of the y coordinates, y2 minus y1, so that would be 3 minus a negative 1 up top, over the difference of the x coordinates, x2 minus x1. That's going to be a negative 5 minus 2. So going ahead and subtracting in our numerator and denominator, 3 minus negative 1 is the same as 3 plus 1. That's going to give us a positive 4. Negative 5 minus 2 down below is going to give us a negative 7. So 4 over negative 7, same thing as saying a negative 4/7 slope. Okay. So asking the question, what is the slope of the line crossing through those 2 points? Well, the answer is that, negative 4/7. We can have a fraction as a slope. And it actually, as a matter of fact, it's often beneficial to have your slope as a fraction, because then we can use this idea of rise over run. A rise being the numerator, your run being the denominator. So let me show you how, if we had these points on a graph, how we could have kind of approached the problem a different way. So let's say we have here the first point, well, let's take negative 5, 3. That could have been somewhere over here. On our graph. And then 2, negative 1, let's say that's somewhere over here. Okay. If we had this on a coordinate grid, and we had the line that crossed these 2 points, it would look something like this. And asking that same question, what is the slope of this line that crosses through the point negative 5, 3 and 2, negative 1? Well, we can use this concept of rise over run to find that slope. How much are you moving to get from this point's height to this point's height? That's your rise, and technically it's not a rise, it's a drop. That's why our slope ended up being negative. And then run is how much movement to the right did you need to make. So if you were actually to count up the grid marks on your coordinate plane, you would see that you're moving downwards 4 units to get from negative 5, to get from 3 down to a negative 1 in your y coordinates, and then you'd be moving to the right 7 units to get from negative 5 on the x, as your x coordinate to positive 2 as your new x coordinate. So if you were to actually count on the graph, you'd be moving down 4 and to the right 7 to get from this point to this point. And that right there tells you that your slope would be that 4/7. So if we thought of it as rise over run, well, our rise wasn't really a rise, it was a drop. That's why we would make that a negative 4 instead of a positive 4. So our rise would be a negative 4. Our run, the movement to the right, was positive 7. And there's our slope. Means the graph drops 4. And moves right 7. So that's 2 different ways we can find a slope given a graph or given 2 ordered pairs. If you're given the graph and you have a coordinate grid, it might be easier just to do this. But if you're not given a graph and you're just given the ordered pairs, you're probably going to have to use the slope formula. Okay. Next, we'll look at finding slope if we are just given an equation. Okay. The nice thing is if we're given an equation that's in this form, we call this slope-intercept. We'll get more into that later in this chapter. But if you have an equation that's set equal to y, we already have it as y by itself, y equals form. The number that is attached to x, we usually use m, the letter m to represent slope. That number is always going to be your slope, or that number that is attached to x. X is coefficient. So if you're asked to find the slope of the equation, 4x minus y equals 8, well, we don't have this equation in the form we want yet. We needed to get it into this form. So in order to do this, we're going to have to manipulate that equation a little bit. So our whole goal is to get the y by itself. And it doesn't matter what side it's on as long as it's by itself. So actually probably the easiest way to do this would be we could move the y, that we could cancel out the y on the left hand side by adding a y. And then we'd have to do the same thing on the right hand side of the equation. That'd cancel out our y's. And that would leave us with 4x on the left hand side of the equals 8 plus y on the right hand side. So now we have a positive y at least instead of the negative y. We want the positive y, but we need to get it completely by itself. So its next step, get rid of this 8. We want to subtract an 8 from both sides. And that will get us the y by itself that we need, as the 8's will cancel out here. So on the left-hand side, 4x minus 8. If you remember your like terms, we can't combine those. That stays just 4x minus 8. And the right-hand side, we do have y by itself. So now that y is by itself, we look over on the other side of the equation. The coefficient of x is that 4. That's the number attached to x. That tells us our slope. Okay. So when you're given an equation, it's as simple as get the equation into y equals form, and then once it's in y equals form, what number is attached to x? That your x coefficient is your slope. And because it's a positive slope, we would know this kind of line would be rising when we look from left to right. It'd be going like this. Whereas remember up here, negative slope, that's why our line was dropping as we moved from left to right. Okay. Another similar example, find the slope of negative 3x plus 5y equals 8. Same idea, we need to get y by itself before we can find this slope. So our first move here is going to be, let's get the x term on the other side. We're trying to isolate the y, let's get rid of the x. Plus 3x. That'll cancel out the 3x's over here. And we're left with just 5y equals 8 plus 3x. Or if you'd rather write it as 3x plus 8, means the same thing. Doesn't matter what form you have it in, as long as 8 is positive and 3x is positive, we're good. And then, well, we want to get y completely by itself, so we would have to divide by the coefficient of y, which is 5. Remember, when we do this, we have to divide by 5 on both sides, which means we're going to have to divide every single term by 5. So every number gets divided by 5. The 5y, the 8, and the 3x. What happens here is we're going to have, well, the 5 and 5s will divide each other out, but we have fractions that will not reduce. 8/5 can't reduce, 3/5 can't reduce. So really we can just keep this equation, all these numbers, in fraction form. So 8 over 5, since it doesn't reduce, we could keep it 8/5, or you could turn it into a decimal if you prefer. 3 over 5 won't reduce, so in fraction form it would just stay 3/5. Okay. Again, if you'd rather have it in fraction form, 8 divided by 5 is 1.6. So that'd be 1.6 plus 3/5 is 0.6. So 0.6x. So now we have our equation set equal to y. We have it in the form we want. All that matters now for us to grab our slope is going to be what is the number attached to x? What is x's coefficient? And it is 3/5 or 0.6. And that's how we find slope if we're given an equation. And we'll finish up the last two examples in the next video.